Okay guys, so we'll start now. So this last chapter is not too difficult. I think part of what makes it so difficult is just the language, the English in it. Because as you can see on page 86, basically we just have lots of problems with lots of words in them, but the actual calculation isn't really too difficult. So our last chapter we're looking at for this semester is probability and sample spaces. Come on. I think a lot of people know this word already, probability. But how would you explain what probability is? Chance, yeah. But that's replacing one word with another. Like, what do you mean by chance? Getting better.
Maybe.
Yeah, maybe. Possibly.
You could get something out of two.
Something what?
Something out of two.
Yeah. You could give it like a tossing a coin. One out of two, something like this, like a fraction. Probably, yeah. That would be a good definition of probability. Yeah. Okay, so probability. One rough definition is just a measure of how likely or certain you are something will happen. It's a way to measure how certain you are that something will or has happened. Now, I think it's important to say that it's not just looking at the future, it can also be looking at the past as well. You know, like if a student does badly on a test, you can ask what is the probability that they did not study for the test. So you can look both forward and backwards. A lot of the time people forget that you can look backwards. They think you can only look forwards, like what is the probability he will pass the test. But you can look backwards as well. You can say what is the probability that he studied for the test. So forwards and backwards is fine for this. And we measure probability with a P, and that is a number between 0 and 1. And 0 and 1 both have meanings here. So 0 means never happens. So if you say probability is 0, it means never ever happens or can happen. And 1 would mean always happens, every time. And of course, in the middle, like 0.5 would mean happens half the time, 50-50. So you can go from 0 to 1. But this is not the only way to do it, of course, because you can do things like this. You can measure probability between 0 and 100%. That's fine too. Same meanings on either side. Okay. You got that? Yep. Right, so next now. So we have... Well, actually, before we're doing that, how would we define what the probability is? When I write this, that's just short for saying the probability that event, whatever it is, happens. Or happened as well. So that's when and in fact it is important that this isn't a special looking P here. I did write 2 lines on purpose. Not this, but this. Okay. Can you see the difference? Yeah. So for example, probability that I flip a coin and get heads. That would equal, yes, 50%, 0.5. So the next thing is, what is the formula for calculating this? So what's the probability of getting a particular event? There's a formula for this, a simple formula, but what would we say it is for those who might know?
A number of ones.
Yep.
Over a number of things.
That's it, the number that you want or desire. Over the total size of everything that could happen. So in the example of the coin, there's only one outcome you want. But there's two possible outcomes, heads or tails. Yeah. Okay, well that one's simple, it's just a coin, but what about if we get into something a little bit more difficult? So suppose, can I scroll down? Yeah. So suppose I do something like I flip a coin twice, and I want the probability of getting heads and heads. Well, for these more complicated ones, for this lesson, I want you to draw something called a sample space. And that's a list of all outcomes. So in this case, you could have heads and heads, heads and tails, tails and heads, tails and tails. So we're looking for this one, yeah, 1 actually, over 4. There's only the one that we want. Yeah.
What does HH stand for?
I want a heads and a heads when I flip the coin. Yeah, because you have two outcomes. Come on, quickly. H is heads, T is tails. On the coin. Heads on the top, tails on the bottom.
Question?
Yeah.
Do they ask me about what do they want me to give? What do I put when I want to get?
Do they ask you what?
Because heads and heads.
Yeah.
Is the question?
Yeah.
Or do I put the heads and heads?
Oh yeah. They'll ask you. They'll say something like, a coin is tossed twice. What's the probability you get heads and heads? Yeah. Okay, write this one down. Let's make the example a bit more interesting now. I know there's other ways to do this. I know, of course, there's other ways to do this. But just for the first lesson, I want you to do this using sample spaces. Can I scroll down? Okay. I'll give you one. It's like this. A coin is tossed 3 times. And perhaps I should say a fair coin. And by fair I mean 50-50 heads or tails. So part A, I just want you to write down the sample space, and B, I want you to calculate the probability of at least 1 heads. And C, let's make this one interesting. Yeah, probability that they're all the same side. So for part C, I mean, when you flip the coin 4 times, you get the same side 4 times for the last one. Okay, so I'll just give you a minute to try this, I do want you to practice writing down the sample space, because it is something you might need for the exam. I know it might take you a minute. So try this one now for 2 minutes. Okay. Got this? Yep. Can I scroll down? Can we try this one? So the first one, A, the sample space. Well, we have 8 possibilities. Heads, 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 tails, heads, tails, heads, heads, tails, tails, and then tails, heads, heads, tails, heads, tails, 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 heads, tails, tails, tails. That's the sample space. Yeah? Okay. B, at least one head. Well, let's count that. That's 1, 2, 3, 4, 5, 6, 7 of those outcomes have at least one heads in them. So the probability of at least one H is 7 over 8. Okay. And then C, probability that you get the same result 3 times. Well, that happens only twice, either all heads or all tails. So for the same, that would be 2 over 8, which is 1 over 4 then. Yep, that's okay. We'll try a different one now. Okay. Can I scroll down? Yeah. All right. Yes. Yes. Okay. All right. So let's see. We'll have 4 people for this. Anne, Barry, Claire, David. Okay. Anne likes Barry. Let's see. Anne hates David. And then we'll say David hates Claire. Okay. Now, what's going to happen now, the 4 of them are playing, we'll say, Secret Santa. Some of you, most of you, maybe even all of you, don't know this game. So you put the 4 names in a bag, A, B, C, D, and each person takes a name out, and they have to buy that person a present. Yeah. Yeah. You take a name out, and you buy that person a present. for Christmas? Yes? So, what I want to know here is what is the probability that the four of them will be happy? So what I mean by that is that Anne gets Barry. No, let's change this not to Anne. Don't want her down twice. Change that to Claire. Anne gets Barry. Claire gets anyone except David. And David gets anyone except Claire. Actually, that's bad for David and Claire.
No problem. If they hate each other.
David hates Barry. Yeah, okay. There we go.
Why are they even in this extended?
Life is complicated, okay? Life is complicated. Maybe it's an office party, and maybe these four people are standing for colleagues. Who knows? Okay. So, I want to know what's the probability that the four of them are happy. Anne will be happy as long as she gets Barry. Claire will be happy as long as she doesn't get David. David will be happy as long as he doesn't get Barry. And there's one other thing that will make you unhappy. If you get your own name. If you get your own name, that's kind of sad, because then you buy yourself a present. So you don't really want to get your name. Yes. So there's four conditions. 1, Anne gets Barry. 2, Claire does not get David. 3, David does not get Barry. And 4, you don't get yourself, because that would make you sad. So what is the probability that all 4 are happy? Now, if it helps you to picture this, you can imagine it like this. Anne, Barry, Claire, David. They come one by one and they take out a letter. So I'll get you started. The first possibility will be Anne first and she gets an A. Barry second, he gets a B. Then third C and then fourth D. Everybody here is unhappy. Why? Each person got their own name. So we don't want this. So we don't count this. Then the next one maybe is A, B, D, C. Is everybody happy or unhappy? Well, there are 2 people unhappy. Who's unhappy here? Well, Anne's unhappy. She got her name. Barry's unhappy. He got his name. Who did Claire get? Claire got David, so she's unhappy as well. Although I could have stopped, because the first one was enough to say no, because Anne got her name. So this one's a no for sure. Okay. So how many possibilities can you see here? How big is the sample space? Is it 16? No, I think it's 24. Yeah. 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 Yeah, every time you take out one is gone. Okay, try this for a minute. It'll take you a minute to figure this out. I've already done the first 2. You have 22 more to do. Go on, write them down. Did you get an answer? No? Okay. Let's have a look at this one now. We can do this one together. Okay, let me switch here because it'd be a little bit easier if I put it on the spreadsheet. Okay, can we see this? Yeah, let me... Okay, these are the 24 possibilities. So straight away, I can forget about these ones. What's the problem with these first? Yeah, what's the problem with these ones? Whoops. Anne got herself, so we can forget about that. Let's look at the possibilities where Barry gets his name. So where does Barry get his name? That would be when the second one is B. So no, 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 no. Okay. Let's cancel the ones where Claire gets her name. So that's where the third one is a C. No, no, no. Anywhere else? That's it. Okay, what else? Let's cancel where David gets his one. So that's where the last one is a D. Where's that? No. There. There. Did I get all of them? Last one's a D? Okay. Now, if I look back at my story, Anne likes Barry. So she'll only be happy if she gets Barry, which means it must start with a B. If it doesn't start with a B, cancel it. So, we can keep these ones that start with a B and cancel everything else. Okay? Claire hates David. So Claire, the third person, cannot get a D. That one is gone. That one is gone. Okay. And lastly, David hates Barry. So the last one can't be a B, which is this one here. As far as I can tell, there's only one possibility where everybody will be happy. So the answer is going to be just 1/24. Which, what's that as a percentage? About 4%, isn't it? 4.17%. There's a chance that is everyone is happy. You must know, in real life, this is much higher than normal, because in real life, it's usually about this. So 4% is pretty good for these 4 people. Not bad at all. Okay.
sorry.
Yeah. Multiply that by 100. Okay, I'll let you try these for a few minutes. I think you can see that the difficult part here is writing down the sample space. Yeah. Okay. You need to try all of these, I'm afraid, because you not only is it the maths, but you need to practice your English. Don't look at me like that, like I was about to, I don't know, kill you or something. English. Yeah. What?
Is there any method we can make we got all the jump.
You mean like for this one?
No, after this one, stop, then something else.
Oh, you missed some.
Yeah.
It's hard. It's hard. It just comes with practice, you know. An important thing to know before you start is how many answers there are. So, for example, with the coin, it's 2 multiply 2 multiply 2. So you knew that there should be 8. And if you don't have 8, it means you missed something. This one, I knew there's 24 because first it's 4, then it's 3, then it's 2, then it's 1. Yeah. So if you know how many there should be, then you can know if you missed some. That's really all. There's no secret way. Yeah. Yeah.
When you say fair coin,
Yeah, everything is equally likely. 50-50.
it doesn't mean the number of coins.
What do you mean number of coins?
So here, a fair coin is 23 times, and now you're going to get 40.
Fair here just means like not a cheated coin, you know, not a coin that's not a normal coin. Yes. What's up? Yeah, this is where like the English is super sensitive. So if I said what's the probability of getting a heads and a tails, or if I said what's the probability of getting heads and tails, they are different calculations. In the first case it's 1/2 because I'm asking you for heads and tails or tails and heads. In the second case I'm asking you for specifically a heads followed by a tails. So it's only because I said the if I said what's the probability of getting a heads and a tails, then that means I do not care about the order. If I said what's the probability of getting heads and tails, then I do care about the order, which I think is what you're asking me. So just because of that, it changes the calculation. And that's what I was saying earlier about how the English is really sensitive here. I think that's worth saying for everybody. Yes.
We don't answer for GMT.
What was my question?
The coin was 3 times.
That's not a question.
Probability of adapting process, probability of handling process.
Okay, I'll have to include the answer then. Guys, just to bring to your attention some English here which would be helpful. If I said a heads and a tails, that means I want HT or TH. If I said heads and tails, it means I want HT. Heads, then tails, HT. Heads or tails, a H or a T. Okay, so there's not much difference between these four ways of asking for this. Now, if you didn't know this, you should write this down, this use of English here. Confusing, I know, confusing. The same.
The same.
Yeah.
Means
HT. Only HT. Only HT.
no
Yeah.
TH.
No TH, no. Yeah.
If I have difficulties in finding toss of a coin,
Say again?
if I had troubles in finding more tosses to the coin, like in here you have to toss it
Yes.
3 times,
Yes.
and I only have 6, and
You
I
missed
got
2 then.
Yeah. So how can I know if it's correct or not?
Eric was asking me that as well. So if you have a coin and you toss it 3 times, each possibility is 2. So the total you should have is 2 times 2 times 2, which is 8. There's no secret way of knowing which ones you missed. You just have to check what you have and see which ones you're missing. So if you tossed a coin 4 times, or 4 tosses of a coin, then that would be 2 times 2 times 2 times 2, which is 16 then. But there's no secret way of knowing which one I missed. You can just know that you missed one. That's why you have to practice them. Yeah?
When it comes to heads and tails,
No, I understand. I remember doing this in school. At the beginning, it's very difficult to keep track of what you've done and what you have left to do. But the only way is just by practicing writing them out. But I understand, I do remember this is difficult at first. But just practice it, that's all that there is to do.
thank you.
Or you can work together, but in English.
Do you want to share?
Yes. The answer's missing. The answer's wrong. That's a big claim to make. Let me have a look. It's true.
I need to consider the order.
For number 3? Oh yes, you should consider the order. Yeah. The woman gives birth 4 times to 4 children. Okay. 16 possibilities for A. Yeah, you only have 4. Yeah, you need 12 more. Yeah. Which one's wrong? For number 3, B. What was my question? What's the probability of 2 boys and 2 girls? There's 6.
Yeah.
And what did I say? I wonder if that is a mistake or if I did something sneaky. Could be something sneaky. Now come on. No. And you do have dots. That is convincing. Alright, that should be 6 out of 16. Are you sure? Alright. But what about how I feel? What about that? Think about that. Too honest. Too honest. Yes.
Your 2C and 2D goes into 4.
Huh?
In the answer sheet.
Can you still see the right answer?
No, I mean the answer for 2C and 2D goes to number 4.
What do you mean it goes to number 4?
That means you have 4C and 4D, which you don't have the question.
Oh, I broke the question up, perhaps.
You brought the answer to the 4.
I don't understand what you're saying. But is it possible to figure out what the answer is at the back, even if it's misnumbered? Now you don't understand what I'm saying.
Maybe.
Okay, then I'm okay. I'll have to fix that worksheet later then if there's some mistakes like that. Yeah, go ahead.
Number 2,
I think someone mentioned that. I have to fix that. Finished, KJ? Take a break for a few minutes now.